Assalamu alaikum guys, my name is Mohammad Amar Khan and today we will be talking about the Bayes theorem. So let's get started. First of all, we will try to understand why is it so important. So basically, this theorem actually helps predict the future events based on the prior knowledge we already have. So basically, we try to build a relationship and we try to understand what the future events are actually holding on. So so it actually helps us to determine what may happen in the future, and we do that by reducing our sample space each time we know that some event has already occurred. And what makes this theorem very famous is that it is very non-intuitional to people, and we will see this point later in the video as well. And basically, this theorem is intended to be used multiple times, and that is why it is used in the artificial intelligence algorithms and also in deep learning. So it actually helps it actually helps build understanding and relationship between different sample values and sample data we have. So we intended to run this theorem multiple times on a given set of data, and that actually helps us predict more accurately on a certain scenario. And likewise, if we don't have any prior knowledge to an event, it seems impossible. And if we will look into its formula ahead in this video. But basically, if we don't have any prior knowledge on a given event, the according to Bayes law, the event is actually impossible to be done in the first place. And it is also a famous quote of Nelson Mandela, which is based on this Bayes theorem. So moving ahead. So basically, this is the formula. Likewise, I said the posterior event which we are trying to predict on is based on the prior knowledge we already have and multiplied by the hypothesis we gave to the scenario. So basically, the likelihood of that hypothesis, and we then normalize it based on the evidence we already have. So this is the main formula of the Bayes theorem, and we actually use it to determine what will happen in the future. Moving ahead, and we have an example ahead of us. So basically, if we suppose we are participating in a Pakistani tournament of guessing a dish while being blindfolded and by only tasting and or smelling the food. So basically, you are in a tournament, and there are several dishes you have to guess while being blindfolded by only tasting or smelling the food. And being a Pakistani, you have no travel history, and your guesses are very much accurate on Pakistani dishes. So, but whenever a foreign dish is given to you, you resort on giving a wild guesses and you just take a wild guess of a country, and it may work or it may not, which is very unlikely for it to work. And for the sake of your ego, you wish to apply Bayes law on this given scenario and try to predict the probability of the humiliation you might get if you wrongly guess the Pakistani dish, because you claim that you have a very good chance that you can predict the dish in the first place. So basically, if we narrow it down into certain events, we can get this tree diagram. So we are given with severely high probabilities of getting a Pakistani dish in the first place, because this is a Pakistani tournament. So there's a very unlikely chance that you'll get a foreign dish in the first place as well. So there's a high chance of getting a Pakistani dish, which is event A, and event B is that you guess the dish rightly. And guessing a dish rightly, given that you were given a Pakistani dish in the first place, is 0.99 as well, which is severely high. And furthermore, you are also given a probability of guessing a dish right when a foreign dish is given. So your basically wild guess got correct, and the probability of that is 0.1. So using these all probabilities, we model this tree diagram, and then we'll calculate the probability of what we are looking for. So we needed the probability of having a Pakistani dish, given that our guess was wrong. So basically, we just substituted the notations here, and then we substituted the notations with the values from the tree diagram, and get our probability as 0.524. And this probability actually tells that that if our guess is wrong, then there's a 0.52%, 52.4% chance that the dish was Pakistani. So that's a lot of percentage, because our half of the wrong guesses are going to be on the Pakistani dish, which is definitely what we do not want to see. So what does it mean actually? So it actually means that Bayes' law is very non-intuitional if you look at it from the first glance. So basically, what we may have thought in the first place is that our chance, if we have 1,000 Pakistani dishes, then our wrong guesses would only be 10, and that is actually correct in the first place, but we didn't think ahead of it. What we do not think is that these wrong guesses may seem a very big number when we compare the wrong guesses of the foreign dishes. And why is that? Because even with high probability of getting a wrong guess on a foreign dish, the thing is that there will be severely less foreign dish given to us in the first place, because the probability of getting a Pakistani dish was 0.99. And so if you get 1,000 dishes of Pakistani food, then you'll only get 10 dishes of foreign food, and approximately 10 dishes of foreign food. So that is very low compared to what you get from a Pakistani food. And that is why if you calculate the probability of getting a wrong dish from there, that is only 9. Those are only 9 dishes. So basically, if we total them all, we have 19 dishes. We have 19 dishes which we have guessed incorrectly out of maybe 1010. And out of those 19 dishes, 10 are going to be Pakistani. So that is why the probability is came out to be very high, and we could have overseen it in the first place. And that is why Bayes law is often misleading to people, because we do not have it in our intuition. And how can we make our intuition better on it? So basically, we have to practice a lot of different scenarios based on these Bayes law, and that is how we can build a better understanding on it. So thank you guys. That's about it from my side, and hope you like the video.